Okay, we're going to see if this series converges absolutely or conditionally, or maybe that series actually diverges. So here's the deal. Whenever the question is asking us if the series converges as absolutely or not, we'll first just take the absolute value and then see what happens, okay? So here we go. This is our check. Go ahead and put the absolute value around the AN formula. So we are looking at this as the sum as n goes from 1 to infinity. And then again, absolute value in action. Here we have -1 raised to the n minus 1's power. And then we have the over 2m plus 1 like this. And of course, absolute value makes negative numbers positive. So this right here will just be all positive ones. On the bottom is always positive already. So this is actually the same as the sum as n goes from 1 to infinity, and it's just 1 over 2m plus 1, like this. And now, look at this. Does this converge or diverge? Well, we can do a quick comparison. Notice that we have 1 over 2 times n to the first power. And again, you can just pick out the n, right? You don't have to include the 2 if you don't want to. So we can do this real quick. This right here diverges. I will show you why. Because we know, yes, we are doing comparisons right here. We know that the series as n goes from 1 to infinity of 1 over n, this right here diverges because, again, just write down this is n to the first power. This is when p is equal to 1, which is less than or equal to 1, and this right here diverges. Then just do the check, whichever one that you want to do. You can do well, actually, you cannot do the direct comparison. You have to do the limit comparison. For the direct comparison, the inequality wouldn't work out nicely, right? So you check by the limit comparison test. And to do this, of course, you just go ahead and take the limit. So I just put down as n goes to infinity. Put down the one that you are trying to figure out, which is 1 over 2m plus 1. Put this down on the top, divided by the one that you know, which is 1 over n. And again, if you include the 2 right here, just include the 2 right here, doesn't matter, right? It's just a constant multiple, doesn't matter. Anyway, let's multiply this by n and n so that this and that will cancel. On the top, this is just n over 2m plus 1. And then take the limit, you see this and that. For this, you do have to include the 2, right? Take the limit, and you see this is just going to be 1 over 2, which is greater than 0 because we did a limit comparison test. So for this one, unfortunately, this right here also diverges because we did the limit comparison test, right? By the limit comparison test. But this is not the original question. The original question is that, does this converge absolutely or not? As we have seen already, if you have the absolute value, this right here diverges, but we also have to check, how about if the original one converges, meaning the alternating version, meaning if we have the -1 to the n minus 1 power, does that converge or not? If so, this right here would be a conditional convergent series. If not, then that will still be a divergent anyway. So here we go. Again, it's not absolute convergence because the absolute value right here diverges, but we have to just go back and just check the original again. So here we go. Well, if you look at this is the sum as n goes from 1 to infinity. We have the -1 to this power. Let's just put it on the side like this. -1 raised to the n minus 1 power, and now multiply by 1 over 2m plus 1. And the reason I want to do that is because this right here will be our Bn. And then perhaps I should say the check right here because this is the same as that, right? So let's just put on equal sign right here. Anyway, here is the check for this. 2 checks. The first check is, well, does Bn go to 0 as n goes to infinity? So let's just put down, if we have the n goes to infinity, does Bn go to 0? This is Bn, which is 1 over 2m plus 1. And look at this. When we put infinity to here on the bottom, yeah, this right here does go to 0, right? I'm just trying to make this thicker so you guys can see better. Because you put infinity to here, right? It does go to 0, so checks. Secondly, well, do we have Bn plus 1 less than or equal to Bn? Meaning, does Bn decrease. Well, this means what? I just have to put the n plus 1 into this n. So we are looking at 1 over 2 parentheses n plus 1, and then plus 1 right here. Is this less than or equal to Bn, which is the original? Like this. Well, of course, let's just do the usual cross multiplication. It's easier this way. This times that is 2n plus 1. And is this less than or equal to this times that, which is 2n, and then this is 2 times 1, which is 2 plus 1 is plus 3. Is this true? Of course, you can cancel out the 2n. Of course, this right here is definitely true, right? So we know that this right here converges by the alternating series test, right? Therefore, you see that the absolute value version didn't converge, but the original version, when you have the -1 and you run through the alternating series test, it does converge. Therefore, we know that this right here converges conditionally, and that's the definition of the conditional convergent. The original version works, right? It converges, but if you have the absolute value, it didn't work. So conditional convergent. Then that's it.